My name is Jackson Carr. My partner here is Calvin Hoople. We will be presenting to you the objective of the Cassini-Huygens mission, the components of the spacecraft, and dive into specific detail on one component of the Cassini-Huygens spacecraft. The Cassini-Huygens spacecraft launched in October of 1997 and reached Saturn in 2004. Since that time, it has been carrying out its mission of examining Saturn, its rings, and its icy moons, specifically Titan and Enceladus. The Cassini-Huygens was designed in order to answer some major mysteries about the Saturnian system. These objectives include investigating the source of heat inside Saturn that produces 87% more energy than the planet absorbs from sunlight, and learning more about the origin of Saturn's rings and the subtle colors that are seen there. This standalone mission is particularly important because it is the first mission whose major focus is on Saturn. It is also fairly different because it was a collaboration between different space programs. The fact that so little was known about this part of the solar system caused major names in space exploration to begin investing in and planning the project. These benefactors included the European Space Agency, the National Aeronautics and Space Administration, and an Italian space agency. The spacecraft is split into two major components, the Cassini orbiter and the Huygens probe. On board the Cassini orbiter lay 12 scientific instruments that will collect data and analyze Saturn's atmosphere, magnetosphere, and information on particle matter in the rings. The Huygens probe contains 6 instruments to take observations while on Saturn's moon, Titan. The components to the entire spacecraft assembly are analogous to the human body. To drive the spacecraft, a power source was required that could sustain flight for a standalone mission this long. 3 radioisotope thermoelectric generators act as the power supply. One 445 Newton engine located in the propulsion module act as the walking legs for the endurance and strength. And orientation thrusters line the sides of the spacecraft to point specific equipment at certain targets of interest. The computers on board act as the brain and process commands retrieved from Earth by the antenna system on board, which represents the ears. Finally, the 12 instruments on the Cassini orbiter act as all the other senses for the spacecraft. The region under the antenna, known as the upper equipment module, contains the remote sensing palette component. This component holds the composite infrared spectrometer, the imaging science subsystem, the ultraviolet imaging spectrograph, and the visible infrared mapping spectrometer, all instruments designated to the Cassini orbiter. The visible and infrared mapping spectrometer, also known as the VIMS, has a visible and infrared channel which allow it to perform its duties. There are 96 visible channels and 256 infrared channels. A pair of imaging grating spectrometers is designed to measure reflected and emitted radiation from atmospheres, rings, and surfaces over wavelengths of 0.35 to 5.1 microns to determine their compositions, temperatures, and structures. The VIMS will map the surface, special distribution of minerals and chemicals of the Saturnian atmosphere, rings, and icy satellite surfaces. An optical palette assembly component and main electronics assembly component exist to make up the VIMS. Both components add up to a mass of 37.14 kilograms with dimensions of 78 by 76 by 55 centimeters. The instrument has a peak operating power and a peak data rate of 27.2 watts and 82.784 kilobits per second, respectively. Thank you very much for listening to this presentation of the Cassini Orbiter by Jackson Carr and his assistant, Calvin Hoople.